Hello viewers, I am Deepti. Today I am going to solve the most important numericals from the board's perspective from the topic the principle of moments. Hope you will find these numericals very helpful for your final revision. Our first numerical is a uniform meter scale of weight 50 GF. Whenever this weight is given, it should be at center of gravity of the given scale. If the scale is meter scale, then it should be at 50 centimeter mark. If we are using a half meter scale, then it should be at 25 centimeter mark. Further, it is given that it is balanced at 60 centimeter mark. Whenever this line is given that it is balanced at this position, it means this is the given fulcrum of the question. These 2 points you should keep always in your mind, where its center of gravity lie and where its fulcrum lie. Then, when a weight of 15 GF is suspended at the 10 centimeter mark, where must a weight of 100 GF be suspended to balance the meter scale? First, we should draw a free body diagram of the given statement. So, for this free body diagram, this is our meter scale, this is our 50 centimeter mark, and weight of the scale is given as 50 GF. So, it should lie at 50 centimeter mark. Next, it is given that it is balanced at 60 centimeter mark. So, this is our 60 centimeter mark. It means this is our fulcrum. These 2 points you should keep in mind. Weight of the scale is at center of gravity. Fulcrum is at the given balanced position of the scale. Now, further diagram when a weight of 15 GF is suspended at 10 centimeter mark. So, this is our 10 centimeter mark, and here the weight is 15 GF. 15 GF weight. And next, where must a weight of 100 GF be suspended to balance the meter scale? Obviously, it should be in the opposite side, but we don't know the position, so we are taking it as x meter away from the fulcrum. Suppose this is at a distance of x meter and the value of the weight given is 100 GF. Now, if the diagram is correct, then further calculation can never be wrong, because these are our principle of moments in the anti-clockwise direction and this is in the clockwise direction. So, according to principle of moment in the anti-clockwise direction should be equal to moment in clockwise direction. According to principle of moments. According to principle of moment, you should write this statement in each and every numerical of this type. Now, anti-clockwise direction. This is the weight 50 GF. And what is its position from the fulcrum? All distances should be calculated from the fulcrum. Fulcrum is at 60 and distance of this weight is 60 minus 50 plus next weight is 15 GF. Its distance from the fulcrum is 60 minus 10. And in the clockwise direction, weight is given as 100 GF, but we don't know the distance, so we are taking at x. So now 50 into 60 minus 50 is 10 plus 15, 60 minus 10 is 50 and then 100x. Now this is 500 plus 750 is equal to 100x. It means 1250 is equal to 100x. X is equal to 1250 divided by 100. It means x is equal to 12.5 centimeter. Where? On the opposite side of fulcrum to balance it. So, exact position is fulcrum is at 60 centimeter mark, then plus 12.5, it means 72.5 centimeter mark is the exact location of this weight 100 GF on the opposite side of the fulcrum. Our second numerical is give the reading of this spring balance if the rule is balanced. It means if the rule is in balanced position. So here you can see at 10 centimeter mark a weight of 6 Newton is hanging. 50 centimeter is the fulcrum position of the scale. And what is the reading of the spring balance which is kept at 20 centimeter mark? So It is given that horizontally balanced meter rule. It means scale is already in its balanced position. So this is our anti-clockwise movement. So we can write anti-clockwise movement due to 6 Newton force, or you can say weight. So what is the value of moment? F into D. Value of F is 6 and D is 50 minus 10. This is the distance. It means 6 into 40. It means 240 Newton centimeter. Now if the scale is in equilibrium position, then moment due to, this is anti-clockwise force and moment due to clockwise force. It means at 20 centimeter mark. So moment due to clockwise force at 20 centimeter mark. We don't know the value of this spring balance. We should calculate the value. So F we need to calculate here. We can take it as W, and then what is D? D is 50 minus 20. This is the distance from fulcrum. It means 30 W. Now according to principle of moment, these two forces should be equal. So 30 W is equal to 240. Now what is the value of W? 240 divided by 30. It means 8 Newton. So what is the value of the spring balance at 20 centimeter mark? Its value is 8 Newton. We should write 8 Newton. In next numerical, two unlike parallel forces of 10 Newton and 25 Newton act at a distance of 12 centimeter from each other. Here the distance is given in between the two forces. So if one distance is x, then other distance should be 12 minus x. Find the point about which the body will balance. It means we should find the position of the fulcrum in this question. So free body diagram will be like this. Two forces, one of 10 Newton and another of 25 Newton are given. Act at a distance of 12 centimeter. Total distance which is given is 12 centimeter. So if we are taking the fulcrum at a position of x distance from this 25 Newton force, then the other distance of 10 Newton force from the fulcrum is 12 minus x centimeter. So now we should write here, let x be the position of fulcrum from 25 Newton force. So now anti-clockwise moment here. This is clockwise, this is anti-clockwise. Anti-clockwise moment in this case is, the value of force is 10 Newton and what is the distance from the fulcrum? It is 12 minus x centimeter. And then clockwise moment is equal to, value of force is 25 and distance of this from the fulcrum is x. Now applying principle of moment, anti-clockwise moment is equal to clockwise moment. So 10, 12 minus x is the distance, 25 and x. Opening the bracket, 120 minus 10x is equal to 25 minus x. It means 35x is equal to 120. What is the value of x? It is 120 divided by 35. It means 3.43 centimeter. So fulcrum is at 3.43 centimeter from the 25 Newton force. And if we want to calculate from the other side, we should take the value of 12 minus 3.43, then our distance from the 10 Newton force will come. By this time, you should have learned that weight of the meter rule is at its center of gravity. If meter rule is given at 50 centimeter, if half meter rule is given, then at 25 centimeter mark. And then fulcrum is at the position where it is given in the question that the scale is balanced or the equilibrium position of scale is at 60 centimeter mark. Then 60 centimeter mark is the position of its fulcrum. Next question on the same basics. A uniform meter scale is balanced at 40 centimeter mark. It means fulcrum is present at its 40 centimeter mark. So this is our 40 centimeter mark and this is the position of fulcrum given in the question. Then next, when weights of 20 GF and 5 GF are suspended at 5 centimeter mark. So first it is given that 5 centimeter mark, a weight of 20 GF is suspended, and then next is 75 centimeter mark. So suppose this is 75 centimeter mark and here a weight of 5 GF is suspended. Now calculate weight of the meter rule. Now we know that weight of the meter rule should always lie at center of gravity. It means 50 centimeter mark, but we do not know the weight of the rule, so we are taking it as W. And we should write here also, let weight of the meter rule be W at 50 centimeter mark. So here moment in clockwise direction is equal to clockwise direction moment. It means 50 minus 40. 50 minus 40, this is the distance of given weight. It means W. This is clockwise moment, and next is plus, what is the next distance? 75 minus from the fulcrum only. 75 minus 40. And what is the value of weight here? It is 5. So 50 minus 40 is 10W plus 75 minus 40 is 35 into 5. It means its value is 175 plus 10W. This is our clockwise movement. Now movement in anti-clockwise direction is this much. What is the value of distance? 40 minus 5, and value of force is 20. So 40 minus 5 is 35 into 20. It means 700. Now according to principle of moment, these should be equal. So 175 plus 10W is equal to 700. So 10W is equal to 700 minus 175, and its value is 525. So what is the value of W? It is 525 divided by 10. It means 52.5 GF is the weight of this meter scale, which should be present at 50 centimeter mark. This is 52.5 GF. In next numerical, a meter stick is balanced on a knife edge at its center. When two coins, each of mass 5 gram, two coins each of mass 5 gram means the weight of total weight of coins is 5 plus 5, it means 10 gram, are put one on top of the other at the 12 centimeter mark. The stick is found to be balanced at 45 centimeter. What is the mass of the meter stick? So the diagram of this question is, this is our meter stick. It is given that it is balanced at 45 centimeter mark. It means fulcrum is present at 45 centimeter mark. And what else is given? At 12 centimeter mark, two coins of 5 gram each. It means 5 plus 5. 10 gram weight is hung at 12 centimeter mark. And then position of center of gravity is 50 centimeter. We have to find the weight. So again we are taking center of gravity position, weight of the meter stick is there, and further completing the question, anti-clockwise moment should be equal to clockwise. Here the fulcrum is at this position, so this is our anti-clockwise moment and this is clockwise moment. So according to principle, anti-clockwise moment is equal to clockwise moment according to principle of moment. Now what is the value of anti-clockwise moment? This is the value of F, it is 10 gram, and value of D is 45 minus 12. This is the distance from the fulcrum. And clockwise moment, the value of force is, we have taken W, and the distance is 50 minus 45. It means 5, and this is W. Now 45 minus 12 is 33, and multiply by 10, 330. So value of W is 330 divided by 5. It means 66 gram is the value of this meter stick, which is present at 50 centimeter mark. In this numerical, a 50 centimeter uniform ruler is freely pivoted at 15 centimeter mark. At 15 centimeter it is pivoted, it means fulcrum is at 15 centimeter point. This is the position of fulcrum, which balances horizontally when an object of 40 Dian is hung from the 2 centimeter mark. This is 0, this is 2 centimeter mark. At 2 centimeter mark, a weight of 40 Dian is hung. Draw a diagram of the arrangement and calculate the weight of the ruler. Now we know that it is a 50 centimeter uniform ruler. It means its center of gravity should lie at 25 centimeter mark. So at 25 centimeter mark, this is the weight of the ruler. We can take it as W. Now this is clockwise moment and this is anti-clockwise moment. Now anti-clockwise moment is equal to clockwise moment according to the principle of moment. Now anti-clockwise moment, what is its value? The value of weight is 40 Dian and value of what is the distance? It is 15 minus 2 centimeter. It means 13. 13 into 40. And clockwise moment is, weight is W and distance is 25 minus 15. It means 10. So 10 W. Now what is the value of W? It is 13 into 40. It means 520 and divided by 10. It means 52. The given unit of weight is 40 Dian here. So 52 Dian is the weight of this meter rule lying at its center of gravity. It means 25 centimeter mark. Now further they have asked also calculate the force with which pivot is pressed. So the total force with which pivot is pressed is equal to this 52 Dian and this 40 Dian. It means 40 plus 52 means 92 Dian is the force which is present at the pivot point. With this, I conclude my today's video. My efforts will be fruitful only when your efforts are added in it. So kindly add your efforts by solving numericals. I am giving 2-3 more numericals for your practice. Kindly solve them and tell me in the comment section. I will be very happy. Thank you for watching till the end. Keep watching, sharing and subscribe to my channel. Thank you.